So we're ready to start working on a problem that involves the law of sines. Here's exercise number 1. Solve the triangle if we are given alpha equals 32 degrees, beta equals 75 degrees, and A, side A, equals 10 inches. So we're given the measures of two angles of a triangle and one side. And what we want to do is we want to find the remaining angle in the remaining two sides. So we want to find angle gamma, third angle, and sides B and C. So we got three things to figure out here, one angle and two sides. I like to draw a picture to try to illustrate what's going on here. I don't know exactly what this triangle looks like yet, so it's a very hypothetical picture, and it's probably not drawn correctly, but it's a good way to get your information organized so that you're setting up the relationships properly. I'm going to label alpha equals 32 degrees. Again, any angle could be alpha, but I'm just choosing this corner. But once I choose the angle alpha, the side across from it has to be side A, so that's 10 inches. I'll put beta equals 75 degrees in this corner, so side B has to be across from beta. My gamma angle is up here, so that's side C. So this is a hypothetical picture. It's not drawn to scale because I don't even know all the measurements yet. Now, we gotta pick something to figure out first. I'm gonna find the third angle first because that's the easiest thing to do. We know that whenever we have two angles of a triangle, it's easy to find the measure of the third angle because the measures of the three angles add up to 180 degrees. So 32 degrees plus 75 degrees plus gamma is 180. 32 plus 75, that's 107 plus gamma equals 180. So that gamma angle has to be 180 minus 107. I guess that's 73 degrees. And we got one of our three bits of information. We got the easy part. Okay. And now we got to find those sides, B and C. And this is where the law of sines is going to come into play. Now, we're solving a triangle. I just want to say we can't use SOHCAHTOA. This is not a right triangle. We cannot use the Pythagorean theorem. This is not a right triangle. We don't have any kind of a squared plus b squared equals c squared here. The nice thing about law of sines is it applies to any triangle at all, even triangles that are not right triangles. So I'm just recopying the law of sines formula. Sine alpha over A equals sine beta over B equals sine gamma over C. It's fairly simple to write that down. Now, how am I going to use it? Well, let's just plug in all the information that we know so far. For instance, alpha is 32 degrees, so sine 32 degrees over A side A is 10 inches. I can just write 10. I don't need to indicate the units here. Equals sine beta sine 75 degrees over B equals, I can now write sine of 73 degrees over C because we know what gamma is. I don't need to write the units on the 10 because we're always going to use the same units in a given problem. We're not going to mix up units or have to do conversions here. In fact, the textbook doesn't even write the units for the lengths of sides, and so you don't even have to worry about that. I like to write the units in these problems because it helps me distinguish the side measures from the angle measures a little bit easier. Okay, now how are we going to use this law of of sines formula. You can only work with two of these fractions at a time. So you have to pick which two to work with. We're trying to set up an equation with just one variable in it. So for instance, if I want to solve for b, I want the equation with b in it, and then I want to use the fraction with b in it, and I want to use that fraction and another fraction where I have all the values plugged in. So I like that first fraction, sine of 32 degrees over 10. I'm going to set that equal to sine of 75 degrees over b. And here I have a little proportion equation with just one variable. Sine of 32 degrees is a constant, a value I can figure out. 10 is a constant, sine of 75 degrees is a number, a constant. So I'm all ready to solve for b here, and I'm going to have to use my calculator to help me out. Make sure you are in degree mode. We've done a lot of work in this class with radians. We've spent a lot of time in radian mode. But for these problems, we need to go back to degree mode. And so I'm in degree mode, and I'm going to calculate sine of 32 degrees. And I have to round off. I'm going to round off to 4 decimal places, 0.5299 over 10 equals sine of 75 degrees. I also need to figure that out on my calculator, 0.9659 over b. And now I'm ready to solve that equation for b. Since it's a fraction equals a fraction, I can just cross multiply here. I think that's the easiest way to proceed. I can take 0.5299 times b equals 0.9659 times 10. And you know, when you cross multiply like that, take this numerator times that denominator equals this numerator times that denominator. It's the same thing that results if you multiply both sides of this equation by the common denominator here of 10b. Get the same thing. So now I want to solve for b, so I'm going to divide both sides by 0.5299. So b equals 0.9659 times 10 over 0.5299. And let's figure that out on our calculators. And 9.659 divided by 0.5299. And I'm going to have to round this answer off also, so I'm going to round it off to 1 decimal place since I have inches. It's 18.2 inches. Our answers may vary a little bit if we round off at different places in a problem. We don't really have a rule in this course about where we round off, so I will give you a little bit of leeway on these. You know, I could have used more decimal places for my sine values, and that would give me a more accurate answer than even what I have here. So now we got b. Let's go ahead and find c. I got to use the fraction with c in it. I'm also going to use my sine 32 degrees over 10 again, since I have all the values of that fraction. And so I'm going to write sine 32 degrees over 10 equals sine 73 degrees over c. And I got some more signs to calculate. We already got 0.5299 over 10 equals, now I need sine of 73 degrees. That's 0.9563 over c. And I got to solve again. So it's exactly the same type of equation. 0.5299 times c equals 0.9563 times 10. And so when I divide both sides by 0.5299, I get c equals 0.9563 times 10 over 0.5299. And let's go through that calculation. And I get, round off to one place, I get 18.0. 18.0 inches is my measure for C. So let's see, we had to find angle gamma, sides B and C. We got angle gamma right here, sides B and C right here. We got this one solved for. I'm going to raise up a little bit to get the whole problem on the screen. And I think I'll stop this video here now. This was the easiest one. We're going to look at some more complicated situations in the next few exercises.